Hello. Today we're going to talk about one-step equations with that are multiplication problems or division problems. Just as we did with the addition and subtraction, we want to do the inverse operation. And remember, inverse operation is when you're doing the opposite. So if the operation is multiplication, we're going to solve it by doing division. And if the operation is division, then we're going to solve it using multiplication. These are some examples. We also have, you'll notice that you have this line here. You can sometimes think about this equal sign as being a wall that separates the two. And remember that you always want to do the same thing to each side of the equation. Okay, so in this case, this is a multiplication problem. 5x is multiplication, is equal to 35. Because it's multiplication, we're going to solve for x using division. And because we're looking for the x, we're going to divide by 5. So we're going to divide each side of the equation by 5. And you'll see that we're using these little fraction bars as our division symbol. This is going to actually save you time and make a lot less of a mess by using these fraction bars. When I take 5 divided by 5, I get 1. And we know that in front of every variable is an invisible 1. So all we have to do is write down the variable. 35 divided by 5 is 7. So we know that x is equal to 7. If I were to check that, I can take 5 and replace the x with 7. And I want to know, does it indeed equal 35? Well, 5 times 7 is 35. And 35 is equal to 35. So yes, it does check out. When it's a division problem like this one, I have x divided by 7 is equal to 3. Well, it's important to get that x by itself, and the opposite of dividing is to multiply. So the number we need to move is the 7. So we're going to multiply each side by 7. When it's written in fraction form, you can also write your product. You can write it in fraction form as well. It makes it easier to say these two cancel out and to be 1, and then x is by itself. And then 3 times 7 is 21. And again, we can test this by doing a check step. We can replace the x with 21 and divide that by 7. And we want to know, does it indeed equal 3? Well, 21 divided by 7, 7 times 3 is 21. So 3 is equal to 3. And so, yes, it does check out. I know it seems silly to do these little check steps on one steps, but it does get, it's a good idea to get in that habit before you start doing multiple step equations. So let's take a look at some examples here. I have 12s is equal to 36. Well, I know that 12s is saying 12 times s is equal to 36. Because this is multiplication, the first thing I need to do is to divide each side by the 12. So I'm going to divide this by 12. And I'm going to divide this by 12. 12 divided by 12 is 1, so I have s by itself. And 36 divided by 12, well, I know 12 times 3 is 36, so it's going to be 3. I can test this by replacing the s with the 3. And I want to know, if I do that, does it truly equal 36? 12 times 3 is 36. 36 is equal to 36. So yes, it checks out. To solve this equation, 13q equals 39, what would I need to do? Yes, you would divide both sides by 13. So 13 divided by 13 is 1. The q is by itself. 39 divided by 13 is 3. And I can do a check step. If I replace the q with 3, is it a true statement? Yes, it is a true statement. 39 is equal to 39, and so it checks out. So solve m divided by 3 equals 29. My operation is division, so my inverse operation would be multiplication. So I'm going to take my m divided by 3 equals 29, and I'm going to move the 3 over by multiplying by 3. That simplifies to just m. And 29 times 3 is 87. And if I do a check step, if I take 87 and divide it by 3, will I get 29? 87 divided by 3 goes in 2. That goes in 9. Yes, 29 is equal to 29. Our next example is s divided by 10 is equal to 17. What is my operation? Correct, it's division. So the opposite or the inverse is to multiply each side by 10. Those simplify down. S is by itself. 17 times 10 is 170. If I were to test this, I would replace s with 170, divide that by 10. Is this a true statement? Yes, it checks out.